Hi, welcome to AI10L, where we are going to code AI with 10 lines. Yes, we are going to build cool AI applications, develop AI strategies that you can use to solve real world problems, and share with your colleagues, and most importantly, have fun. This is going to be an AI series for healthcare professionals. And my name is Abdullah Mansoor. I work for Intel for 10 years. I'm a machine learning engineer, an author, and the trainer. And I'm going to lead these sessions for you. How do computers see an image? Images are one of the basic building block of AI for healthcare. Let's take a look at this figure. Wow, it's a grayscale image of an X-ray. So this can be represented in computer with the help of a matrix, and in Python this can be a NumPy matrix. Look at this image. This is an colored image of a cell of a human tissue. Wow. So this can be represented by uh, three matrices, which represents red, green, and blue channels. Cool. Images are the one of the most important basic building block, and you really have to master how they're represented in computers. And for that, a tip here is that you need to master the Python data structures like lists and dictionaries and NumPy arrays, because this is going to help you a lot. One of the challenges these days is not the lack of information, but the abundance of the information. And if you want to make a progress and you're not able to make a progress, then I can also offer you some free consultation. You can see this link on the screen to get this free consultation with me. So how do computers learn from images? Just like doctors or pathologists who are expert in diagnosis, they read from books, from conferences, and then with the experience, years of experience, by looking at different images and their diagnosis, they are able to make those decisions. Similarly, computers and machine learning models learn from from these data sets. So basically, a data set is a collection of images with some known information about those images. So when these data sets are then fed into the machine learning models, it could be neural networks or any other kind of model. And these models are trained to perform certain tasks. These tasks could be pattern recognition, feature detection, classification, or segmentation. So what are data sets? So this matrix, as we discussed, could be representation of an image, and a label, which is known information about image, like a diagnosis. Okay, so this is the basic building block of a data set. I see. The International Skin Image Collaboration. Wow, they are gathering the data sets of skin cancer diagnosis. Wow, this can be super helpful for us. Whoa, so here we're looking at an Isaac dataset example with 4 images and the diagnosis, which could be malign and benign or malignant. So let's get our sleeves. Let's roll up our sleeves and get coding. So we are going to use this Replit.com environment for our coding platform. The reason I choose this because it's web based and it has all the dependencies in it. So it should be very simple for even a very beginner level users to start coding. So we're going to go to Replit.com and then we are going to create our account. Since I have an account, I'm just going to log in with my Google account here. So this is how the Replit look like when it's opened. A working environment for Python. So we are going to go and we're going to create a Python REPL, and then we're going to select the Python with data science because it comes with many dependencies. And then this is where we are going to once it's created, we are going to work here. Okay, our next step is how to install Python Isaac CLI library. So this dataset that we talked about have a Python library that can allow us to download images. So first let's look into how we are going to install this library in Replit. So we're going to use pip, which is the Python package manager, to install a Python library called Isaac CLI, which is the this dataset provided library. So now once this pip command is completed, my library is installed. Okay, so this is done now, and we can now use the the installation to download the images. Okay, the next step is to download an Isaac dataset images. So we're going to write this command Isaac image download hyphen limit 1 and the folder name data. You can change the number to anything you like, but usually this free REPL has a limited storage. So now this data is downloaded, and then I can look at the content of this data using the ls command. Okay, so how to visualize a CSV in a Replit environment? So we're going to go into this folder that we just downloaded, and we're going to use the gnumeric command to load the metadata.csv file. This is going to create a new window in the Replit environment where we should be able to look at the CSV file. So this CSV file should be very simple right now because just one image, but if we have more images, we will see more rows in this. This is pretty much like an Excel environment. Okay, let's look how to visualize an image in a Replit environment. So we are going to use gimp command to load an image. So I'm going to write gimp and then the name image, and then it's going to open this gimp tool, which is the Linux tool, and we should be able to look at the images. Okay, so the main idea here is that in this video that we educate our users to familiarize with the datasets because it's one of the most important component of building AI applications. So we have shared 4 commands to download and visualize this dataset. We shared the pip command to install this Isaac CLI library, and then the download command to download the dataset, and then we use the gnumeric Linux application for opening the CSV file, and then gimp for opening the image file. The next part of the video is more like a preview of what we are going to do in one of our next videos. For this video, the main goal is that is to get familiarization with the data sets. So what we are going to do, I have downloaded, let's look at our preview. So I downloaded a dataset with 900 images. This is 2016 challenge training dataset from the Isaac CLI library. And so this is the view of there are 900 total rows here, which are corresponds to those 900 images and their relevant information. Okay, so what I have done is that I have extracted the features from the metadata.csv. So I have processed those images and converted those images, these matrices, into 127 features. And then now this training features.csv has the information about total 7. Basically we took the 80% of the images from the previous data from the downloaded one. So this has now basically the data that we'll use for training of and the leftmost column is the label, and this label is basically showing the one of the diagnosis types. There are total 4 diagnosis types in this data set. So here is one line code that actually will going to train the model, and once the model is trained, is going to use this model. We can use this model to start diagnosing. Isn't it cool? Just one line? Wow, not even 10 lines. Let's see how it works. So I'm just showing this here in a different environment. This data set that train features.csv, and then here my code is stored in a Python file, just like I just showed, and then I'm going to run this script, which is just a one-liner code. Now it's going to start the flow. I'm going to parse the CSV file, and then it's going to start the training. And this training process may take some time because it's going to do something extensive. It's going to train 7 different models in parallel and different type of models, and it's also in the meanwhile is going to do some post processing of the data set. So for example, it's dropping some of the constant columns because this data is useless. Now what it's going to do is that it's once it's trained the model is going to create this report, and this is the report of the 7 models that it has trained. So what we are seeing on the screen is the report of the 7 models which were trained using during this training process. So the top performant is the stacked and sample machine learning model, and we're going to learn more about those different model types in our future videos. But what we are seeing here is that the mean average error of zero point 0.2, which is roughly 80% accuracy. So with such a short time, and if you are getting 80% accuracy, with some further efforts, we can definitely improve our accuracy. And then once the model is trained, we can use this model and deploy in a more realistic application to, for example, give a second opinion to a doctor so that it has more information, and we can do so many more things about it. Isn't it cool that we are able to train the model with just one line of code? Wink, wink. Actually, I did a trick. It was a couple of lines of code, like 5 to 6 lines. But even then, I mean, we are able to train the model with 80-20 split, and this model can predict the accuracy, 80% accuracy. Isn't it cool? So yeah, let me know how do you like this content. Also, let me know your questions with the comments. I have provided below the link of my YouTube channel, and I really want to hear your questions and comments. So I've opened a few channels, a few slots in my calendar for free consultation for you. If you like this content, then don't forget to follow, share, follow, like, and share with your colleagues.